So hi, here in this video I'm going to explain the solutions to number 2 of assessment 1 on topic 3, expansion and factorization of algebraic expressions. So in the previous video I have shown the solution to number 2a and 2b, so here we'll start with number 2c. Okay, so we have to factor the following expressions. So k squared minus 144. Okay, in number 2a and 2b, we factored the expressions using the highest common factor. Okay, so we look for the highest common factor or common factors, and then we factor that out to obtain the factored form expression. Now, some expressions do not behave like you won't see any common factor on the first and second term or among the terms. So, for instance, k squared minus 144, if you look at k squared minus 144, there is no common factor for k squared and 144 aside from 1. Okay, so how do we factor this kind of expression? Okay, some special forms that we discuss in the classroom is the one with a squared minus b squared. Okay, and we learn, we actually showed the equivalent expression for a squared minus b squared, and that it came from a plus b times a minus b. Okay, if we apply the expansion, so this will become a squared, and then, so that's first and first, we apply the FOIL method. First and first is a, and then outer will be minus ab, inner will be ab, so you just multiply, and then the last will be minus b squared. And in any expression following that format, a plus b and a minus b, will result to an expression equal to a squared minus b squared, because the middle term, the two middle terms here will basically be 0. They cancel each other out. Okay, so if you will start with the given expression a squared minus b squared, then the factored form will be a plus b times a minus b. Again, provided that the expression follows the format a squared minus b squared. Now, in some textbooks, they call this kind of expression as the difference of two squares. Okay, they call this a difference of two squares or the dots. Okay, because it's the difference, if it's the difference between the two squares, a square and b square. Okay, so any expression following the difference of two square format can be factored by using a plus b times a minus b. So how is k squared minus 144 follow this format? So k squared is already is a square. Okay, so it's a difference, so it's given minus. But 144 is also the same as 12 squared. Okay, so this is like your a square minus b square, where a is k and b is 12. So if I apply a minus b or a plus b times a minus b, then that means, so my a is k, so k plus my b is 12, and then k minus 12. Okay, so you can look at this as k being the square root of k squared, and 12 being the square root of 144 or 12 squared. So k plus 12 times k minus 12. Now, if you may ask, is it the same as k minus 12 times k plus 12? Yes, the order is not important, so you can write k minus 12 before k plus 12, or k plus 12 before k minus 12. Okay, so again, just to summarize the idea, if you're given an expression that you want to factor and it follows the difference of two squares format, then you just have to apply the formula, we could say the formula a squared minus b squared is equivalent to a plus b times a minus b. Okay? So let's go to the next. So in the next one, you were given, so this is 2D, you were given 24m squared minus 150. Now, whenever you factor, so we have learned two types already. Factoring out the greatest common factor, and then factoring if the given expression is a difference of two squares. So in any expression, your first option, the first that you have to check is there any common factor? Okay, you have to look for the greatest common factor first before applying any special factoring techniques. Okay, so 24m squared minus 150, I could see that 24 is an even number and 150 is an even number. So we could say that this number can be divided by 2. But we have to check, is that the highest number that can divide 24 and 150? So we could try, like, I know 24 can be divided by 6. So let's see if 150 is also divisible by 6. That's 2 times 6 is 12. This is 3. And then 4 times 6. Not 4 times 6. 5 times 6 is equal to 30. Okay, so 150 is the same as 6 times 25. So meaning, for now, we could see that maybe 6 is the highest common factor. So we have 6, we can factor out 6. And then m is just in the first term, so you cannot factor out m, or even m squared. So 6, when you factor out 6, it means you're dividing 24 by 6, and that is 4. And then you have m squared, okay? And then 150 divided by 6, coming from this computation, is equal to 25. So initially, we have applied factoring through the highest common factor, and that is 6. Okay, now be very careful when you factor, because sometimes factoring the greatest common factor is just the first step. Okay, so what I want you to check is that what happens to the remaining expression. Okay, so far we know that if an expression behaves as a difference of two squares, then we could apply the equivalent expression for the difference of two squares, and that's a squared minus b squared equals a plus b times a minus b. So we check if 4m squared minus 25 follows the difference of two squares. So first, it's a difference, yes. But is 4m squared and 25, are they both squares? 4 is a perfect square, so yes. M is raised to 2, so it's a square. 25 is a perfect square, so it follows the form of the difference of two squares. So meaning, so after factoring 6, so the 4m squared will be divided into two factors. Okay? And if you remember, a squared minus b squared is a plus b times a minus b. So that simply means we get the square root of a squared. Square root of 4m squared is 2m. 2 for the 4 and m for the m squared. So that's 2m and m. See? A and a. And then for b, that's 25. So your b is 5. Okay, so if b squared is 25, then b is 5. So this is 5 and this is 5. And then you just put plus and the minus sign. So the factored form of 2m squared minus 150 is 6 times 2m plus 5 and 2m minus 5. Okay, so again, looking at the problem, we applied two different ways, two methods to factoring this completely. First, we apply the HCF, or the highest common factor. And then on the second, we apply the difference of two squares. Okay, so we needed 2 steps to factor the expression completely. Okay, so that's for this video. So we stop at letter D. In the next video, I'm going to continue with letter E. Okay.